Okay, good morning everyone. Welcome to APNIC eLearning web class. Now today is the 6th of January in 2016. This is the first e-learning session that we are conducting this year. So Happy New Year to everyone. So today is Wednesday. It's 11 a.m. from Brisbane in Australia where I'm doing this class. And the first topic that we will be covering is all about DNS and DNSSEC. Now the next two sessions are also DNS related, but this one is an advanced topic. So here we will be discussing the details. Okay, this is more of an introduction to what DNSSEC is and how you can use it, what are the different resource records that you will be looking at, and things like that. Now, before we proceed with that, I'd just like to very briefly introduce myself. My name is Sheryl Hermoso. I work as a training officer for APNIC. As you probably all know, APNIC is Asia Pacific Network Information Center. We are the regional internet registry for the Asia Pacific region. Now, for the training the training team, we do conduct sessions to different parts of the Asia Pacific region, and the topics that we do cover, as you can see there, network security, IPv6, DNS and DNSSEC, internet resource management, and we also conduct routing, BGP, MPLS, anything that is related to internet technologies. Now, this session is provided for free to anyone who wishes to attend the classes, and it runs for 1 hour. So at the end of the session, I will be asking you to fill in a very short survey for me. The link is not here yet. I will be posting them at the end of the session. So if you have time, please feel free to fill in those forms so we know what things we needed to improve to be more effective in conducting these types of sessions. All right, so let's proceed with our topic. So as I've said, this is more of an advanced topic regarding DNS. So I'm hoping that the attendees somehow have some understanding of what DNS is, or maybe are DNS administrators or zone administrators in some respect. So DNS is a very useful, it's a very useful system, right? It's one of those technologies or protocols that have been developed early in the internet age. Okay, we've had DNS, we've been using that since the early 1990s, and it's very useful. And you know the reason why. Everybody uses that. And DNS is a way of mapping names into numbers, one resource to another resource. Now, I don't really want to go to the details of the basics of DNS. That's an assumption that we are making here, that you have those ideas. But I wanted to focus on the security aspect of DNS. Why is that? As we know that DNS is very useful to everyone, a lot of users, I would say majority of internet users, rely heavily on DNS. What you type in on your browsers are the domain names rather than the internet numbers, right? Typical users know how to reach google.com or apnic.net or any other website, but don't have an idea what an IP address is. Okay, but what really happens is DNS is just a third-party system that you check for these types of mapping, but okay, once it has that IP address, the packets are created and it's directed to, okay, the destination address will be the IP address of that server. That's how it works. Now, with that in mind, as we know, DNS is a critical infrastructure. Now, where are the problems when it comes to the DNS system? So, DNS, in a good respect, is a distributed hierarchical system. It starts with the root, and then you have the top level domains or TLDs. Then we have sub-level. Okay, it branches out to different nodes. Okay, that comprises your entire fully qualified domain name. Now, who serves as DNS? Who provides information to those queries? Those are DNS servers. In DNS, we have something called master or slave, or primaries and secondaries. And you can see that here. You have these master and slave, okay, but they both answer to queries. Who does the query? Your machines. Sometimes you also call that as resolvers. Resolvers check with a recursive DNS server or a caching DNS server, okay. Sometimes it provides both of these functions, and it answers those queries going there. So you see those transactions that are happening in between different DNS servers, resolvers, recursive servers, and your authoritative name servers. Now, inside either of these master or primary or secondary servers, you have zone files. Zone files are either databases or simply a text file that contains information about those mapping between different resources. Okay, so administrators can either log into those servers and update these manually. Sometimes they have remote servers that does that. They can do dynamic updates that doesn't require any changes or any restart in the name server daemon, for example. And so with this kind of setup, where are the possible problems? Where are the possible issues? Of course, in a distributed system like this, anything can happen in between all of those transactions. At the same time, the data itself that is in your zone file, how sure are we that it is correct? Okay, so for example, I queried for www.apnic.net. I send that query to my recursive server, which is this one here, and then my recursive server will do a recursive query or question from the root server going down to the top level domain until it reaches this authoritative server, right? So that's how DNS typically works. Now, the question here is, all right, we follow that kind of like hierarchical query, but the moment that the answer comes to this resolver, to my machine, how can I then verify that the information that I got, that the IP address of www.apnic.net that I got is actually correct? The answer is there's no such thing. There's no such way of verification of the data that you receive. So that's why things like cache impersonation or cache pollution, you probably have heard of these things. Data spoofing, okay? At some point, I think around early 2000s until 2005, this was a big problem, okay? Someone can impersonate to be the primary or authoritative server and then give you wrong information. Instead of pointing you to 203.176.189.2, for example, it points you to a rogue server, okay, that imitates exactly how the server, the website, for example, that you want to access looks like. Okay, so cache pollution is a big problem. So how do we address these issues? One of that, okay, and the main thing that we will be looking at to protect DNS is DNSSEC. So DNSSEC stands for DNS Security Extensions. So as you can see, it comprises of a few different RFCs, RFC 4033, 4034, and 4035, that adds a few things, that adds some extensions to the existing DNS protocol that is defined in the RFC. So what we're trying to do here is, as explained in the previous slide, in the diagram there, we want to protect the integrity of the data in DNS. Okay, the integrity of the data. We all know that DNS data is public. Anyone can query those servers, even say a caching server, if it's still within its cache, and obtain that information, right? So it's a public data. So in security, we have three different goals that we always look at: confidentiality, integrity, and availability. So among these goals, our focus in DNSSEC is the second one, which is integrity. Okay, in integrity, we want to make sure that the data that we receive is coming from the right source. It is correct. There is a way of verification. And how do we do that typically? So I'll just give you a brief example. So how many of you probably here sends and receives email on a daily basis? Most of us, right? So when you send an email, okay, if you want that email that you receive to be coming from the right source, what do you check? Sometimes we have such thing as we call as a digital signature, okay, digital signing, wherein the sender of the data signs it with a private key and then sends it to you. Now, once you receive that data, okay, you search for the public, or maybe you already have that in your system. You use the public key to verify the contents of the data. So you know that it's coming from the right source. So here we are using public and private key pairs. Okay, this is cryptography that we're talking about. We're using public and private key pairs, or asymmetric key cryptography, to provide that form of integrity. So in DNSSEC, okay, in a similar way, we will use that. Okay, you will see later on as we discuss, we will be using public and private key pairs. More specifically, if you've heard about KSK, key signing keys, and ZSK, zone signing keys. But more on that later on. But suffice it to say that at this point, you understand what DNSSEC is all about. And that is this line here. It wants to provide you peace of mind, for example, that the information that you got is correct, okay, by checking the integrity of the DNS data. Okay, so we're using digital signing here, we're using public key cryptography, okay, and essentially we're providing authenticity and integrity of data. And one other thing that I would like to discuss later on, and you can see that in this second line as well, chain of trust. Okay, it follows the chain of trust from the root going down to the authoritative name server. Now, do we have any questions at this point? Okay, before we proceed, I'd like this part to be clear to everyone. All right. Okay, someone is typing a question there. I'll wait for you to finish. In the meantime, I will continue with the next slide here. How DNSSEC works. Okay, so we understand the purpose of DNSSEC. Okay, we know it's basically to provide integrity, to prevent cache pollution, and things like that. So how can we do that? In the current DNS specifications in the RFC, it's not there. It's not part of that. So with additional RFCs, we are introducing different resource records, additional resource records. And through this, we can sign our existing records. When I say records here, these are resource records, right? A record, pointer records, name server, NS records, CNAME, and things like that. Okay, so these records, we are going to sign them. They are the data, and we are going to sign them with our private key. Okay, similar to the email example that I gave you earlier. We're going to sign these records with our private key. Okay, and then for that to be verified by the recipient, what do we need? What do they need? They need your public key, right? You sign it with a private key, you provide the public key so that they can verify that thing that you signed, that data that you signed. Okay, so that one will be also published. Okay, so two things that you're going to publish now. The signed record, which is the signature here, it will be published through DNS, and also the public key, which is also published in DNS. Okay, this will all be part of your zone file. Okay, so again, you sign the data. Okay, the signed data itself, the signature, will be published, okay, as another resource record. Okay, the public key, the corresponding public key of the private key that you use to sign, will also be published on your zone file. Okay, another thing there, child zones also sign their records with their private key, and parent signs the hash of the child zone's public key to prove the authenticity. Now, these two lines here is an indication of the line that I told you in the previous slide, which is chain of trust. Okay, there should be a way for the parent to know or to direct you to the correct child. The parent knows how to get to the child, and that is through this. Okay, the parent will sign a hash, and they will have a corresponding record in the parent's zone file. Okay, so those four things are very important. So okay, let me just skip that for the time being. So let's go through this. Okay, so first of all, okay, how can we achieve those steps? We have new concepts that are introduced in DNSSEC. One of them is we will have new resource records. Okay, later on we will discuss about chain of trust, key generation and signing, and validation. Of course, this too has got something to do with the use of public and private key pairs, and we have to sign our zones and then re-sign them when it expires. Now let's go to the first one, new resource records. Now aside from A record, pointer records, CNAME, NS records, SOA records, and all of those records that are defined in DNS, we are introducing these 4 new resource records. Okay, and let's go back here for a little bit. Okay, now records are signed with private key to prove its authenticity, the signature is published, and the public key is published. Now let's go to these resource records. The question here is, how do we publish the signature, and how do we also publish the corresponding public key, right? So these are the 2 resource records that does that. RRSIG stands for Resource Record Signature. It's a signature over the RR set, okay, made using the private key. So you sign a set of resource records. Now the thing here, so example, you have your zone file. You have a record for your website, another A record for your FTP, another A record for your another, say, DNS, or another mail server. So you have these types of records, different records within the same zone file. Now we don't sign each of these resource records. We sign a set of these records. So if you have 3 lines next to each other that are all A records, they are grouped together and then it is signed accordingly. So an RRSIG is not a signature of each resource record in your zone file. It is a signature of a set, an RR set, which is all our resource records that have same attributes, same resource record type. Okay, so the signature goes into this RRSIG resource record. The next one is your DNS key. So you sign it with a private key. Now you need to publish the public key. That will go into this file, the DNSKEY resource record. Okay, this is the public key that is needed to verify your RRSIG. Now we also have this delegation signer. I'll show some examples of these records, by the way, in the coming slides, so you have an idea what to look for in your zone file. Now this next one is delegation signer. So I've told you about chain of trust. Okay, I've told you that the parent needs to know, and it will have a hash value of the child's key. So it's actually contained in a DS record. So when you sign your zones, there will be a DS record generated at the same time, and then you have to send it to the parent zone. Now the parent zone will add it to his zone file. That is your chain of trust. Okay, that is your pointer to the child zones. Okay, another one here is NSEC, or later on we have NSEC 3. This stands for Next Secure. Now one thing that we want to also be able to know is that if I search for a particular subdomain, if it's non-existent, okay, how do I know that? Of course, there is no information that is coming back to me. So how do you prove the non-existence of a file? That is through NSEC. With NSEC, this is actually a kind of a list of all the resource records that are following before and right after a particular record. Okay, it indicates which name and resource record type follows that particular resource record. Okay, now I'll tell you a little bit about NSEC 3 later on, but it's kind of like a more secure version of NSEC. Okay, so essentially in a gist, it's something like this. So you have your RR sets. Your RR sets are signed with a private key to prove its authenticity, to prove its integrity. Okay, now this signature will then be published using the RRSIG resource record. Okay, Now the DNS key again contains the public key, and it's also published next to the RRSIG so that you can verify. When you do the query, for example, say I want to know the IP address of apnic.net. So I do my query, dig at DNS server for APNIC, www.apnic.net. So I got a reply. If I'm DNSSEC enabled, okay, or if I do dig and then add a plus DNSSEC there, it will not just give me the A record that I'm looking for, it will also give me or provide me with the RRSIG, the signature corresponding to that record. I will also have a copy of the key, the public key, by getting the DNS key record so that I can do my verification there, right? And then child zones are signing their own records. Parent will sign the child zone's DS record to prove its authenticity. Okay, so any questions? So those are the 4 resource records that we are introducing in DNSSEC. So this is an example of the first one. As I've said, DNS key contains the public key. Where is the public key here? It's this one here. Okay, this is your public key in another format. Aside from that, you also have an indication whether this key is of what type. So if it's 256, this is ZSK. If it's 257, it's KSK. Now we haven't discussed about ZSK and KSK yet, but suffice it to say that you will have 2 different types of keys. You will generate 2 types of keys. One is ZSK and one is KSK, and this is an indication which one it is. This 3 here is your protocol octet, and then this is your DNSKEY algorithm number, and this whole thing, as I've said, is your public key. It's shorter because it's in base 64, unlike, like say, if you open up a public key as usual, it's usually longer than this. Now, this is just a comment at the end here, okay, because when you generate your public and private key pair, you'll have a corresponding key ID. Now, this shows you what that key ID is to avoid any confusion as such. Another thing, a very important thing that you can see in DNSKEY is some timing metadata, okay? It's just a comment, okay? It's for users, it's for the administrator, so you know what type of key it is, when was it created, when was it published, and when was it activated. Because you can have different values for these creation, publish time, and activation time. In this example here, they're all the same. This is a KSK, key signing key, and once we have created this, we also started using and publishing it. It's activated by default. Now, when you generate your key, this is a typical behavior, but again, by adding some parameters, you can change these values. For example, you want to create it now, but you don't want to activate it until maybe 1 week after. You can do that. Or you want to create it now, publish 3 days after, but activate a week later. You can also do that. Okay, so these are timing metadata that is very important when you do your key rollovers. Okay, key rollovers are significant in DNS. All right, next one here is your RRSIG. So I've said this is your signature. So here, this example shows us one NS record here and another NS record over there, right? So 2 NS records. So as I've said, what we sign here is the RR set, not individual resource records by themselves. So for these 2 resource records, we have this signature, right? This RRSIG. This is a signature over the RR set. So if you notice, this is an RRSIG for the name server resource record type, and somewhere here, there's a number. This is an indication of how many resource record types are in your RR set. All right? So that's the RR type. That's the digital signature algorithm that was used. And this is the number of labels in the sign name, which is 2 because we have 1, 2 name server records that are, or in the RR set that are signed here. Now, another very important thing to note is this, okay? This is as you probably will guess, this is a date, a time, 2012, 12:02. So that's December 02 of 2012 plus the hour, minutes, and seconds there. So what are they? This first one is your signature expiry. The second one here is the date that you signed it. What do you notice? They are a month apart. So when you generate your signatures, because you will have to do that to be able to sign your records, the keys themselves don't expire. The keys do not expire, but of course at some point you'll have to change it because it becomes weak the longer that it is exposed out there. But the signature, so when you sign using the key, when you sign the resource record, the signature itself actually has an expiry, which in this case by default is about a month. So from November, okay, it expires in December. So what happens here? Let's say because you signed the whole zone file, okay, you signed the whole zone file, which has a lot of resource records. Now, if you make changes at any point in between this expiry, you'll have to re-sign your zone file again. You have to sign it again. Okay, every time that you make modification, you delete something in your original zone file, you have to sign that zone file again. Now, within a month, for example, that probably your data are mostly constant. It doesn't change very often. So if it reaches the signature expiry, then okay, actually you shouldn't allow that to happen. Make sure that you have, say, some scripts in place that re-signs it every 30 days or so. Why? Because once it's expired, it cannot answer for any DNSSEC queries as such. Alright, so just make sure that you are aware of this when you perform DNSSEC. Actually, the initial part where you sign your records, okay, once you understand the entire concept in itself, once you sign the records, that part is quite easy. Most DNS software can do that quite easily these days. It's part of the software itself. Before, you have to like have an external software that does just the DNSSEC, but most of the software kind of does that now. Like say, for example, with Bind 9 versions, they moved from 9.4 actually, they have that capability to sign your zones, to implement DNSSEC. But the majority of the issues thereafter will be signing your zone every time that it is about to expire. Okay, we will talk about that. I think I might have some slides that discusses that a bit later on. So any questions on this? Okay, this is the NSEC record. Okay, next secure. It provides you with a chain of the resource records. Okay, that corresponds or that follows your record. So for example, here you have myzone.net. It's an NSEC record, and notice here you have a few things: ANS, SOA, MX, RRSIG. So again, the main purpose of this is one, to show you what is the next record that comes after that. Okay, two is to provide or to prove the non-existence of a domain. So if, for example, you have NSEC records that shows that, but for some reason there's another record that is inserted in between. So instead of ANS, SOA, MX, you have another one there, maybe another A record. What does that mean? There is a big possibility that the data that you received have been compromised, right? Or the zone file itself, somebody was able to modify it and insert a new resource record in there, okay? Which is one of the issues that we have with DNS. So NSEC in this example is very useful to tell us that if it's not in this list, then it's not supposed to be there. It should be non-existent. Now, one of the problems with, that's another example of NSEC there. I don't have it here, but one of the problems that you can possibly find with NSEC record is that it shows you in plain text all of those resource records, what follows after the other. So you can do zone booking Okay, there are actually like tools or simple codes that can easily do this. So the way to solve this problem of zone walking is to introduce NSEC 3. So with NSEC 3, you don't see this as a link here in plain text format. This is actually encrypted. Okay, so you see some gibberish set of numbers and letters there instead of this plain text. So that is NSEC 3, and it avoids, or it kind of solves the problem with NSEC that you can do zone walking. Okay, now the last one here is a DS record. Again, once you sign your zones, there will be a file. And this file usually is your name-ds set. That's another file. It's not part of your sign zone. It's in a different file in itself. But when you open it, it has two lines, two DS records. Okay? Now this should be added not on your zone file, but it should be added on your parent's zone file. So what do? Once you have signed your zone, okay, once you have done that, you'll notice a few files there. One is your sign zone, and then your DS record, your DS set record. Okay, so we open that up, and then you either send the whole file to your parent zone, either, I don't know, they might have different ways to do it. Okay, and I'll say some of the hosting providers, they have a form for members to upload these DS records. Okay, if we're talking about reverse DNS within the WHOIS database, there's also a way for that to do. Just add the DS record field in your WHOIS object. Okay, again, this should be added in the parent zone, not on your own zone. It's just a key ID and some algorithms there. Now, why do we have, it's not very clear, this should be pointing this one there. Now, why do we have two DS records? Okay, you should add or upload all these two. So one has a value of 1 and the other one is 2. One is for SHA-1, the other one is SHA-256. So this is just the hashing algorithm that's used for this. Essentially because a lot of like DNS software don't have support for both of these yet, so it can it has the option to use these two types of hashing algorithms. So you just provide both of these to your parent zone. So that's a chain of trust, and as I've said earlier, if it's not clear to you yet, a chain of trust establishes a chain of trust from the parent to the child zone. Now, for a very long time, okay, there was kind of an issue with implementing DNSSEC, not because it's hard to implement and all that, but the root has not been signed yet. So even if you sign your zones and all, there is no direct chain following from the root going down to your say your name server or your domain. Okay, but nowadays, of course, the root has already been signed, so you just need to check whether your parent are also implementing DNSSEC and they have signed their own zone. Okay, so chain of trust coming from the root, going down to the top level domains, to the sub-level domains, all the way through to your name server, okay, or your domain, should indicate that chain of trust. Okay, now what happens here is the parent does not exactly sign the child zone, but it indicates a pointer going to that child zone. The parent does not have to sign the child zone, otherwise that will be a lot of work, a lot of administrative work, because every time that you need to make changes in your zone file, you'll have to again go to the parent, right? So we don't want that. So the parent signs a pointer going to the child zone. So that's why you have to add the DS record going to the parent and not to you. All right? So, okay. Any questions so far? So we have discussed about the different resource records, how we use them, what are their purposes, and by doing so, you kind of should have an idea of how DNSSEC works, right? Now, one thing is still missing there. Now, we have to sign zones, therefore we needed to use keys to do that, right? And as I've said at the beginning, we are using asymmetric key cryptography. With crypto, with asymmetric crypto, you must have two types of keys. One is a public key, the other one is a private key. Okay, since we're concerned about integrity, we're using the private key to sign our zones, and then we are publishing the public key using the DNSKEY record, right? So that one is clear. But how do we now generate those keys? Okay, there are many ways to do that depending on the software, of course. But what does that imply? So you have to have those keys and sign the zone. Okay, again, if you have to make changes on any part of the resource records within that zone file, you have to again sign the zone. Now, with that signing, that will have an effect on the other types of records, such as the DS record, right? And that DS record will have to go to the parent zone. So if you have a pair of keys and then you change your zone file maybe every day or every couple of days, what happens is every time you do that, you have to go back to your parent zone and then tell them or give them your new DS records. So it has to follow that chain every time. So it's a lot of administrative work. Okay, it's a lot of administrative load to do that. So to address this issue, instead of using just a single key pair, we are going to use two key pairs. Okay, that's what I've mentioned those words earlier. It's like key signing key or KSK and the Z signing key or zone signing key. Okay, KSK and ZSK. Now, using a single key or both keys is an operational choice. If you read the RFC, it tells you that it's actually optional. You can have just one key. Perhaps if you're not changing your zone file very often, that's okay. But if you do change that very often, then it only suffices it to say that you probably must have must use two key pairs, right, to avoid that administrative load. So how do we do that? So that zone signing key and key signing key, which one is used for what? ZSK will be used as per normal. You have, as I've explained, if you have your zone file, you sign it. You have your resource records, your RRSIG, you sign it. So zone signing key is what you use to sign that. Okay? Now, we have another key, the KSK, which now signs the zone signing key. So I guess you can see that from the name itself. The zone signing key signs the actual zone file. The key signing key signs the other key, which is your zone signing key. All right? So your key signing key will be pointed to by the parent zone, and it's kind of like your secure entry point to the system itself. Okay, it's not clear there, but yeah, that's what it means. So zone signing key and key signing key. Now there are defaults. Default value or default duration where you want to use these keys. Zone signing key, you normally change that every few months, for example, every 6 months, or maybe more often if your data is considered, you want to be more vigilant and you want your data to be more secure. And KSK, you normally can change that, say, every year. Okay, so this is where the some of the issues are. Like if you are going to re-sign it at a later time, at a later date, how often should you do that? Okay, what should you do? When should you do it? Okay, if I sign it now, what is the effect? Because in DNS you have TTLs. So if you change something now, it doesn't mean that will be propagated as quickly as you wanted. So we have to take all those things into consideration. So timing parameters are very important also with DNSSEC. Okay, so as I've said earlier, these signatures, the keys in itself that you generate, KSK and ZSK, do not expire, but the signatures that are generated using them have a validity period, which is by default 30 days. Okay, so if it's already expired, it will not validate. It will not validate if it's already been expired, so you have to re-sign the zone. That's why I told you, okay, once you have this in place, make sure that you have a system that signs it every 30 days, maybe a small script, or maybe you can do it manually, just remind yourself to do it, or most DNS software have the capability to re-sign it also automatically for you, right? Okay, so a few things, a few statistics all over the world. This one is the actual DNSSEC deployment in ccTLDs. I think what you need to do on your end is to double check whether your TLD, okay, say for example, it's APNIC.net, is .net signed. Okay, your example, check whether your TLD, or maybe you're using ccTLDs, check that it's already been signed. Okay, or your immediate parent, have they signed their zones? Okay, because you want the chain of trust, you want to follow the chain of trust. Now, what if your parent is not signed yet, which is a typical issue, right? Okay, I can't really implement DNSSEC because, well, my parent has not signed their zones yet. Okay, so let's say I'm using training.apnic.net. Okay, maybe apnic.net has not signed it yet. So how can I now sign training.apnic.net? Now, one of the solutions that was used for a while is using third-party systems, okay, where you can add your DS records, they can verify for you, but they're third-party, it's not following the typical chain of trust. But as much as possible, you want your parent zones, of course, to be signed. Okay, any questions so far? Now, the things that we have discussed are mainly for zone administrators when you have a domain, okay, or an IP address block that you want to, of course, sign. Okay, if you're the ones providing DNSSEC data. Now, the other part of this is the DNSSEC validation. So if you remember the diagram at the beginning where you have the resolver, it goes to the recursive server goes to the authoritative name server, right? So that part, okay, that recursive server there should do DNSSEC validation. Okay, once you receive information about the record that you were querying, you should now validate. When I say validation in this case, so I received the A record, I received the signature, the RRSIG record. So based on that, I also have the DNSKEY. I have to check whether the signature is correct. Okay, you have to check whether the signature is correct based on the information, the signature, and the public key that I have got. So to be able to do that, if you're running a recursive server, okay, if you're running a recursive server and you're using bind, okay, it's as simple as adding a DNSSEC validation set to yes. So once you do this, okay, once you've done this and then you queried for a DNSSEC enabled data, you should see an AD bit, okay, meaning authenticated data. Okay, of course, if you're doing from your browsers, you don't actually see that. Maybe you want to download something, maybe a plugin to verify this for you that will have an indication, a green or red mark on your browser screen if it's validated or not. But if, say, for example, you're familiar with DIG. DIG is a utility within DNS where you can do simple queries. So if you do DIG for a particular domain, and then plus DNSSEC, you'll see there's some information, right? Not just the information that you wanted, but also the authoritative servers, what host was used to query that, how many seconds it took, and also some flags. In the flag part or portion of the response, you should see there different flags. One of them, if it's authenticated, you should see an AD bit. That's to say that your DNSSEC, so your recursive server, okay, implements DNSSEC validation, and the information that you've got have been authenticated. It's all correct. Okay? So these are some of the things that you can use. Okay, you have a validator on your browsers. You can, again, as I've said, you can install some plugins. Okay, there are some online tools. These two are quite good to verify Say if you want to check your implementation or someone else DNSSEC data, you can do that. Or if you're a user and your DNS server in your organization, your company are not implementing DNSSEC yet, but you want to use it or you want to try it, there are some open DNSSEC validating resolvers that are available. Okay, one is from DNSOERC. They have one for bind, implemented with bind, and one with unbound. And of course, the popular Google Public DNS can also do DNSSEC validation, right? Okay, any questions with DNSSEC validation? Okay, I hope that you understand the difference between the two, even if you don't have your own domain that you want to sign, okay, but you're providing DNS services to your customers, to your organization, you can use DNSSEC validation. But what happens if, say, when you do validation and apparently the signature that you got does not match? Meaning possibly it's been compromised or maybe it's wrong data that you got. What happens? So by default, the DNS server will not forward any answer, okay, any response to the resolver that asked for it. So if I'm querying for the IP address of training.apnic.net and I didn't get a response, what happens in my browser is it's just trying to resolve it, right? It's just like it will time out. It will not get anywhere because I don't have the IP address. So that's one thing that you should look at. So if you are implementing DNSSEC validation, make sure that you inform your customers about it, and you must be ready to answer questions about how come when I'm trying to access this website, it's just blank. Okay, I can't access these websites. Maybe it's because of implementing DNSSEC validation. Can be a lot of other things, of course, but it can also be about DNSSEC validation. Just be aware of those things. All right. So going back to implementing DNSSEC for your domains, these are simple steps that you can follow. Okay. One is, of course, this is an example with bind. Okay. As you know, bind is the most popular DNS software that's available out there. So these steps are what you use when you're implementing DNSSEC with bind. So first thing is to open up your configuration file, named.conf, right? And then you enable DNSSEC by adding these two lines, DNSSEC enable yes, DNSSEC validation, set that to yes. Okay, what's the next step? Of course, you need keys to sign your zone. So the next logical step is for us to create our key pair. So I've said you have the option to just create one, but it is recommended to have both KSK and ZSK. So with KSK, well actually with both, the command that you will use is DNSSEC keygen. Now this is a utility that comes with the bind software, comes with a bundle. So I just need to know where it's located. So you run this DNSSEC keygen, you provide what algorithm you're going to use, the number of bits in your key can be 1024, 2048, can be 4096 or even longer, depending on what you want. And then minus n zone, and then the your domain. Okay, you provide your domain. Now, if you don't provide all of these information, let's say minus A and minus B there are defaults. I think the defaults are RSA SHA-1 for the algorithm and 1024 bits. Now, the main difference between KSK and ZSK here when you're creating key pair is that you specify when you're creating KSK, you add a word KSK there. And also the number of bits. 1024 is typical for ZSK, but not for KSK, right? Why? Because ZSK, you change it more often than KSK. KSK is exposed out there for about a year. So you want to make it stronger. So usually it's double the number of bits that you use for your ZSK, right? And then after you do that, you publish your public key, okay, by adding that onto your zone file, and then you sign that zone. Okay, there is another utility, it's called DNSSEC sign zone. DNSSEC sign zone, and then you specify the keys that are going to use the KSK and the ZSK, and the zone file and the domain that you're going to cite. Once you have done that, you actually have the option to specify an output file name, but if you don't, it's usually your original name, say for example, apnic.net or db.apnic.net. Okay, that's your zone file name. So if you don't specify another name, by default, it will just add a dot sign at the end. This is another file that is generated. Okay, but if you try to compare this with the old zone file, notice that the size is much bigger than the old zone file. Why is that? Because you now have the additional records that we have discussed. You now have your RRSIG, your DNSKEY records, your NSEC or NSEC3 records added onto that zone file. So you try to open that file and see the differences between them, and you should recognize all of these resource records that we have discussed. I've given you some examples here as well. Okay, so the next thing that you do after you have signed that zone is to, of course, update your configuration file. In named.conf for a specific zone, you specify what will be the file name for that zone file, right? So instead of using the original, say, db.apnic.net, since now you have a new zone file that contains all of those new records, you have to update your named.conf to point to that. So update that to db.apnic.net.sign. Okay, so those are the main steps, and of course, before you make it publicly available, make sure that you test it. Make sure that it is working by using simple utilities such as dig. So dig at your name server for your domain, okay, and check whether you can add a plus DNSSEC there, and you can see there other values such as your RRSIG and your DNSSEC key. And from my recursive server, again, you should see an AD bit. Okay, those are the ways that you can check that. Now, I think this next few slides just covers each of the steps in more detail. So this is the DNSSEC keygen utility that I've told you about. If you want to just simplify it and use the default, you just specify DNSSEC keygen minus F KSK if it's KSK. If not, just use the DNSSEC keygen command and then the zone file, and that should do it. Now this generates you 4 files, K something, meaning it's a key, okay, and then there's a number there. If you open that up, it will give you some timing metadata and tells you whether it's a key signing key or a zone signing, because sometimes it can be confusing. They're all just like key names plus some number there, which is your key ID. So it's hard to tell by just looking at the file name whether it's a ZSK or a KSK. So if you're confused, open it up and you'll see there's some comments that tells you whether it's KSK or ZSK. Okay, so those are the commands for that one. And then when I said to include it, this is how you do it. Okay, when you add it to your zone file, you just point to that key file for your ZSK and your KSK. You can also copy the whole thing and add that as a DNSKEY resource record in your zone file. But the easiest is, of course, to just use the $include utility there. Okay, now signing your zone, this is the command, that's DNSSEC sign zone. Notice that you're providing your KSK and ZSK here. And then your output is something like this. If your original zone file is db.myzone.net, your output will be db.myzone.net.signed, right? Which is, of course, bigger in terms of the file size because it now contains other resource records. Okay, last one there is, of course, to publish your zone. Okay, make sure that you're pointing to the correct zone file, which is the output of your signing. And then this is the command to test. Dig at your name server for your domain. You add a plus DNSSEC there, and sometimes it's better to add a plus multi-line so it's more formatted, better to look at it. But without that, that should also still work. Okay, these are examples. I'm not sure if you can see this very clearly, but these are examples when I do a dig command. You can zoom it in once you have the slides later on. So you have your answer section, you have your A record. At the same time, you also have the RRSIG. the signature. Notice that because we did a full query there, with the authority section, which is the name server record here, it also comes with the corresponding RRSIG. So it's always like that. So whenever you get a response, you get a record that you asked for and the corresponding signature for that resource record. Okay, now to publish your DS record, as I've said, you have to contact your parent zone. Now there are proposals in IATF to have this more automated, but right now we're not there yet. Okay, so you have to do it manually through the form that is provided to you by your parent zone. How do you do that? This is an example with GoDaddy. They just have this form to create your DS record. So based on your file, you have to fill in this form. If you're doing, it's not here, but if you're doing, say, signing your IP address block, reverse DNS, you can also log into your MyAPNIC account and then update the object, okay, the the domain object there, which is for the IP address, and then add the corresponding DS record. All right, so any questions from the class today? We have 7 participants. Did you all understand what we have just discussed? Okay, hopefully the concept is quite clear with you. And I've lined up some steps for you to follow. So if you want to do this at a later time, maybe you have a DNS server sitting somewhere and then you want to play around with it, at least you have some steps to follow on how you can do this. You have the commands that you can use. It's all in the slides. So if you want a copy of the slides, that's all on our FTP page. So any more questions, guys? Can we look at KSK and ZSK? Well, I don't have the examples here. This is not my laptop. This is a laptop that we use for training, so I can't just like show you that from here. But it's basically just a key. You know, if it's a KSK, it's much longer compared to the ZSK. So if you want a copy, then you can probably send me an email, and I can maybe give you more explanation about the KSK and the ZSK. So just email us at training@apnic.net because I can't exactly show you details about them just using this machine. Sorry about that. Okay, another question here is, the zone should be signed, only the main domain or all subdomains are also must be signed. Okay, so I'll get back to the ZSK and KSK question. I'll just like answer this one. The question was basically, do you sign the main domain or all the subdomains should be signed? Now, it kind of depends. If you have a domain, okay, say if you have a zone file essentially that contains your domain, right? In DNS, we have what we call as zones and domains. When you say domain, it's everything from .node and everything that is underneath that, all the nodes underneath that. That's your domain. When you say zone, that is an administrative space. So say, for example, with APNIC.net. Okay, .net is, of course, hosted by someone, and then APNIC.net has been delegated to APNIC. So we manage our own DNS and everything. And then another example, maybe let's say training.apnic.net. It has been delegated to another administrator, so we manage that whole thing. So in that sense, of course, you have different administrators for each. You have to, of course, sign that separately. But if you're saying that, say, you're the administrator for, I was trying to see where you're from, say websurfer.com.np, and then you have somewhere there, you have a subdomain called, say, host1.webserver.com.np, but it's still under the same management, meaning that you add your resource record and the same zone file, then you just sign it at one. So it's more about delegation, okay? So if you're familiar with how delegation works, once a subdomain has been delegated to someone else, then they have to do the signing separately as well. Okay, so same administrator in one zone file can do it all just once. Does that answer your question? Was it Fadley? Okay, the next question there is there a time period to change the KSK and ZSK? So I've been explaining this for the whole session. Essentially, okay, as I've said, the keys in themselves do not expire. So say I generated my KSK. So where are those things? So this is my command to generate, right? So I generated my ZSK and I generated my KSK. Okay, so it doesn't exactly expire, but you're exposing them out there. Okay, and as with all keys, okay, it's usually not a matter of how strong it is, but it's about time. Okay, and the longer that you expose something, the keys out there, the weaker it actually becomes, because you're giving more time for them to try and crack it, right? So while it doesn't expire, you have to generate those keys, and the idea is, or the common practice is to generate new keys for ZSK more often than KSK. With KSK, you usually do it every year, or at the least maybe every couple of years. With ZSK, you do it more often, maybe every 6 months, maybe every 3 months, or every month, for example. It depends on how sensitive you think your data is. Now, what expires actually is the signature. So once you have signed your zone file, okay, you have to do it regularly. You can use scripts to do that, or you can ask your DNS software, because some of them should have the capability to do the signing automatically without you doing anything on your end, or you do it manually. I've showed you one example with some parameters. I think, let me just find where that is. I think it's this one. That's your RRSIG, right? That's your signature. Notice that there is a time there. So within 1 month, it actually expires. So that means, that's just by default. You can change these defaults depending on your requirement. But by default, it is every month. So if you say don't do anything within 1 month, you did not change anything, you did not modify, you did not delete or add any new resource record, okay, then that means that within a month from that time, it will expire. So you have to sign it every month, okay? And of course, every time you make any form of changes and additions and modifications, you have to re-sign the zone. Okay, so I guess beyond the first time that you implement this, okay, the thing that you have to be aware of is how to maintain it and sign it on a regular basis. Okay, any other questions? Is that clear, Prabhu? Okay, if you have any further questions and if you want me to expound on this thing, you can always shoot me an email, send me an email at training@apnic.net, or my email address that you can find in the slides there, and I'll be happy to help explain them in more detail to you. All right, are there any other questions? Okay, I don't see anyone typing there, no activity in the chat anymore. So I have here the link to the survey. If you can just please try and fill in that survey for me, that will be very helpful. I'm also going to write down that link on the chat panel. So this is the link to the survey, or the link there that you can see if you can link to it. And if you want a copy of the slides, you can download them from our FTP page, which is on this link. So let me just copy that one for you. this one here. Okay, so I hope it has been helpful for everyone in this session. It is a lot to take in. Within 1 hour, I'm not sure if you can fully comprehend, and if you have big, say, big DNS implementation, you're managing many different zones, this task can become very easily become very tasking for you or for the administrator. So take your time to test it. Test with one domain, see how it works for you. When you're familiar with how your DNS software does DNSSEC, then you'll feel more confident with deploying the whole thing afterwards. So again, if you have any questions when it comes to resources and everything, please feel free to send an email to our help desk or to ourselves training. And with that, let's end this session for the day. If you want more on basic DNS and DNS security, we have the 2 other sessions at 1 o'clock and at 3 o'clock today. So you can also log in using the same login details that you've used here. So with that, thank you very much for attending our first e-learning session for the year, and I hope to see you another time. Bye-bye.